Chapter 5 Review. Leo's Deli sells ham and turkey sandwiches. They have 3 types of bread to choose from: white, wheat, and rye. Which tree diagram shows all the combinations of meat and types of bread sold at Leo's Deli? Well, they have ham and turkey. So I have ham and turkey, just turkey. That just looks weird. And then ham and turkey. And then I need white, wheat, and rye. So white, wheat, and rye, that's correct. White, wheat, and rye, that's correct. Pretty confident A is my answer. D does not have white, wheat, and rye on each one. Take a look at number 2. The places Teresa can choose to go on Friday or Saturday are listed below. She can go to one place each day. Which list shows all the possible outcomes of one place and one day? So we have Friday and Saturday. This is where I might actually use what is called an area model. So on Friday and Saturday, she can go to the concert, movie, park, or gym. I go Friday concert, Friday movie, Friday park, or Friday gym. She can go Saturday concert, Saturday movie, Saturday park, or Saturday gym. So I know I have to have a total of 8 combinations. So it's 1, 2, 3, 4. A can't be it. 1, 2. C can't be it. 1, 2, 3, 4, 5, 6, 7, 8. So we have a choice between B and D. We have concert Friday, concert Saturday, okay. Concert movie, no, you can only do one event on the day. So B, concert and movie, cannot be a combination. Therefore, D is my answer. Let's take a look at number 3. Number 3 says, of 50 random customers, 62 ordered blue phones, 74 ordered pink, and the rest ordered black. Based upon the results, how many of the next 75 customers would you expect to order the black? Well, first off, we have to know how many ordered black in the first place. So that is 150 minus 62, which is, let's see, 8, 6 to 14 is 8, minus 74 pinks, which is 14 blacks. Okay, so we have 14 blacks. Would you expect means that I need to do a 1 table. They're asking about black out of total. I am given, although I did have to figure out there was 14 blacks, it's kind of given information. So it's 14 out of 150, and they want to know out of the next 75. Well, since 150 divided by 2 is 75, I know that 14 divided by 2 is 7. So I would expect 7 of those customers to choose black. Now let's take a look at number 4. Karen has 5 red marbles, 4 blue marbles, and 3 white marbles. I know total marbles already is 9, that's 12. What is the probability that she draws a red marble, then a blue marble? Red marble, then a blue. Each action gives a fraction. Probability of red times probability of blue. And I know this is a little bit different than what we are used to, but and in probability means to multiply. This should be on your brain dump that we do every day. So the probability of a red is 5 out of 12 times the probability of blue is 4 out of 12, and then all we're doing is multiplying fractions. You can multiply across and then simplify if you choose, and that is totally fine. I choose to simplify before I multiply. I like working with smaller numbers better. 4 and 12 go down to 1 and 3. So now I have 5 times 1 over 3 times 12, which gives me 5 over 36. Therefore, my answer is C. Let's take a look at number 5. A bag contains 9 red tiles, 10 blue tiles, and 6 green tiles. This is a total of 25 tiles. I always like to find the total first. Knowing that I'm working with probability, it's always got to be your favorable outcome out of total outcome. So I always know I need my total. A tile is randomly drawn from the bag. Which statement is true? The probability of a red tile is 30%. Well, for red, you have 9 out of 25. I know I can multiply 25 times 4 to get it to 100. So that's actually 36 out of 100, which is 36%. So I don't think that this one is true because it is 36%. So it's not A. The probability of drawing a red tile is 36%. That part is true. The probability of drawing a red tile is 36%. That part is true. The probability of drawing a red tile is greater than the probability of not drawing a red tile. I'm going to say that that is not true because the probability of not red is everything but the red. So 16 over 25 is greater than 9 over 25, so I don't think that I agree with B. I think that it's less. So now I'm going to look at B and C. So the probability of not drawing a red tile is 54, and the probability of not drawing a red tile is 64. Well, remember, the not means it's complement. And if you go back to the notes that we just took, we know that to find the complement, it is 100% minus the 36%, which will give you the percent difference. So 100 minus 36 is 64%. Therefore, C is my answer. Let's take a look at number 6. During the regular season, a baseball team won 50 games and lost 30. Based on this record, how many of the next 16 games can the team expect to win? Now again, I need to know total games. So if they won 50 and they lost 30, it sounds like they played a total of 80 games. And we want to know how many they will expect to win. So this is a won table. So win over total. They won 50 of the 80. That's given. And they want to know out of 16. Well, this is very interesting. So we are going to multiply 50 times 16, which is 800, and then divide by 80. So 80 into 800 is 10. So I would expect them to win 10 out of the 16 games. Number 7. Ava forgot to study one of the chapters for a history test, so she had to guess on 2 multiple choice questions, which each had 4 answers. What is the probability that she got both questions correct? Let's think about this. If you have multiple choice questions, how many of those answers are usually correct? Well, usually it's only 1 out of 4. So you have the probability of correct on the first question times the probability of the correct on the second question. Because remember, it's 2 multiple choice questions, so each action gets a fraction. So the first correct is 1 out of 4 times the second correct of 1 out of 4. There's nothing to simplify, so I have 1 times 1 is 1, and 4 times 4 is 16. She's got a 1 out of 16 chance of getting both of those correct. Number 8. Each player in a game will roll a number cube and spin the arrow on the spinner 1 time. The numbers on each face of the number cube and the shapes on the spinner are shown below. How many different combinations of one odd number and one shape are possible? So we're only looking at odd number, and I want to point out, this is something we did not write in our notes, if they want combinations, you can use what we call the counting principle. And that's all you do is you multiply the outcomes together. So for odd numbers, you have 1, 3, 5. So there's 3 of those times the shapes. There's 1, 2, 3, 4, 5, 6. There's 6 shapes. So that's a combination of 18 shapes. My answer is A. Let's take a look at number 9. Number 9 says the arrow on each spinner shown below will be spun 1 time. Which of the following diagrams shows all the possible outcomes when each arrow is spun once? So I have 1, 2, 3, 4, and then blue and green. So I need to make sure that they each have 1, 2, 3, and 4, and then blue and green. So this is 1, 2, 3, 4, 1, 2, 3, 4. It has no blue and green. And oftentimes you guys say that you don't know how to explain why you got an answer or why you did not get an answer. But this is a perfect example. On A, it doesn't look right, but why does it not look right? And we can tell it's because there's no blue and green. So if you struggle to explain how you got the answer, sometimes it's okay to explain how you didn't get an answer. B, it doesn't say that you're spinning the spinner twice, so B is not it because we only spun the number spinner once. C says 1 blue green, 2 blue green, 3 blue green, 4 blue green. I like this one. I think that might be my answer, but let's check D. 1 blue blue. There's not 2 blues on the spinner, so you can't get D, so it has to be C. This is saying that you can only get blue, and there's not, each number can get a blue and a green. There's not duplicate blues. So C is our answer. And I wrote not duplicate blue or green, because again, sometimes we don't know why we didn't get an answer, but you can tell us why not. Number 10. Via is buying a t-shirt for her brother. Her choices of teams, colors, and sizes are shown below. How many different combinations? I am going to use the counting principle, which means all I'm going to do is multiply all the outcomes together. So for the teams, I have 1, 2, 3, 4. For colors, I have 1, 2, 3, 4. This equals 16. And for sizes, there are 3. So I can multiply 16 times 3 and get 48. So there's a total of 48 different combinations. Number 11. At an assembly, 7 out of the first 10 students who entered the gym were carrying a backpack. Based on this information, if 700 students were at the assembly, how many students could be expected, one table, to be carrying a backpack? So we have backpack total. Our given is 7 out of 10, and they want to know how many out of 700. So it looks like I'm going to be multiplying by 70. So 7 times 70 is 490. So I'm going to bubble in 490. Number 12. The list below shows the number of shirts of different students that Savannah sold one day at a store. Shirt with vertical stripes, shirt with horizontal stripes, shirt with school mascot, shirt that is plain. Based on these results, what is the most reasonable prediction, looks like I'm doing a one table, of the number of shirts with a school mascot that will be sold out of the next 165 shirts. So I guess I kind of need to add these up. So 6 and 4 is 10, 18 and 5 is 23. So we have a total of 33 shirts. So make my one table. They want to know school mascot out of total. I'm given, although I had to find the total, it's still given information because I can figure it out what I've been given. So I'm given 5 out of 33, and they want to know out of 165. So it looks like I'm going to multiply 33 times 5. Let's see if that works, because I'm 33 times 5 is 15, yeah, times 5. So 33 times 5 equals 165. Therefore, 5 times 5 equals 25. So I would expect the next one to have 25. And number 13. A cafeteria manager surveyed a random sample of students at a school to determine which of the two meal choices they prefer. The results of the survey are shown below. Okay, so I am going to add these up, which is 48. Based on the results, how many of the 240 students at the school can be expected? That means I'm doing a one table. So I'm going to go ahead and set that up. And they preferred chicken. So chicken out of total. I am given who preferred chicken. 30 out of 48. And they want to know how many out of 240? 48 to 240, I don't know. I'm going to multiply these two together and divide by 48. So 240 times 30, and 12, 6, 72. So I have 7,200 divided by 30. Take a 0 off. 3 goes into 7 2 times. Oh, it needs to be dividing by 48, not 30. I was wondering why I was getting my same answer back. That'd be dividing by 48, not 30. Let's try that again. Let's do 7,200 divided by 48. 48 goes into 72 once, so subtract 48. 24, bring down to 0. 48 goes into 240, I believe it's 5 times. 48 times 5 is 40, 24, that's it. Minus 240. Don't forget that last 0, so it's actually going to be 150.